All right. Good evening, all. Since others are still joining, we'll wait for like 2-3 minutes and then start. What about my audio and video, those who joined? It's working fine, right? Yeah, it's working fine. Okay. We'll wait for like 2-3 minutes until others are joining. Right. Okay. Okay, it seems everything is fine. We'll start. Fine, listen. So today we'll be starting electronics. Now, since we covered, we have already finished current electricity. Now, today onwards, we are moving on to the last lesson here that we'll be doing in this class, right? The last unit actually. Last unit we'll be doing in the class, that is electronics, right? So when it comes to electronics, right? First, I'll explain you what the contribution here is. Contribution means the amount of marks you are going to get by learning electronics, right? From electronics in our paper out of 100, right? And as a lesson, this is again a lesson with some kind of different aspect you are going to see, right? Kind of current electricity is linked, and you are going to see some different aspect you haven't seen before, right? In physics, something like that, a different aspect, and most of the things are unique here for electronics, and the main link is with electricity, right? Some links are there, some things are there, they are very much unique to electronics. Link වෙනවත් තියෙනවා, නැතිවත් තියෙනවා, වැඩ ගොඩක් තියෙනවා. And most importantly, when I share the flyers also, I shared the same thing, I mentioned the same thing, right? Most importantly, when we consider the essay question coming from electronics, right? When we consider the essay question coming from electronics, right? No doubt, that is the essay you can do, or we can do with the least time, right? No doubt about that. Now, usually our usual time for an essay question is 30 minutes. So our usual time for an essay question is 30 minutes. But when it comes to electronics essays, right, if you check for last 10, 15, 20 years also, this pattern is same. Right? When it comes to electronics questions, we can complete the essay question within 10 to 15 minutes if you are totally familiar with everything, right? Another thing is, when it comes to electronics, you can't master this just by knowing one part of electronics, right? Knowing one part, we can't touch the essay, right? Because always that essay is connected to everything, links to everything inside electronics. So therefore, as a whole, you have to know everything about electronics, right? When you are familiar, when you are comfortable with these things in electronics, right? Usual time for electronics essay question is, it varies around 10 to 15 minutes, right? So simply that is the essay question we can complete with the least time, right? That is one advantage, right? You can have when you learn electronics properly, right? ඒ කියන්නේ electronics පොඩ්ඩ පොඩ්ඩ දැනගෙන මොකුත් කරන්න බෑ. electronics ඔක්කොම ටික දැනගන්න ඕනේ, right? Otherwise, if you just touch and go electronics, you won't be able to do essay questions in electronics, right? Simple as that, right? But when we see everything to this real depth we have here in electronics, to the actual depth, real depth, right? Then you can easily tackle what is coming in questions, right? Something like that, something like that. එහෙම comfortable වුණාට පස්සේ in less than 15 minutes of time, there is an essay question you can secure 30 marks in 15 minutes, in less than 15 minutes basically, right? ඕක තමයි මේකේ තියෙන main important point එක, right? Okay, මම distribution එකක් කියන්නම්. I will mention the distribution of marks also, right? So let's see, right? As a heading, write down electronics. Right? So distribution is like this. Listen first. Distribution is like this. When it comes to MCQs, right? It's around 4 to 5 MCQs coming, right? It's usually 4, right? It's around 4. Then 4 marks here. It's around 4 MCQs, 4 marks here. And no standard structured essays from electronics. Sometimes, this is very rare, but sometimes some electronic parts can be linked to electricity structured essay, right? But I won't consider it as a structured essay because that is not a definite question, right? Say no structured essays, no definite structured essays, right? When it comes to essays, you have a definite essay, right? That is essay number 9B. 9A is current electricity, 9B is electronics. 9A is current electricity, 9B is electronics, right? When you answer the essay question from AB, right, you can either answer A or B, right? Then A or B is electricity and electronics. Electricity is කරනවා නම් electronics එක කරන්න බෑ, right? electronics කරනවා නම් electricity එක කරන්න බෑ, right? There are AB questions. 9B, 9A is electronics, 9A is electricity, 9B is electronics. Then for this question, there is definite 30 marks, right? Which means 7.5. So basically, right? This is around 11%, 11%. This is a 11% lesson, right? So usually we call this a 10% lesson. Right? But actual allocation here is around 11%, 11 to 12 right? So if there's anyone who need to have an idea about this, you can take this down before we get into the lesson, right? If anyone needs to have an idea about this allocation, because always it's better and you have to know the allocation when you learn something. When you are learning a new lesson, learning a new unit, always you have to know the allocation, right? Then only you know what's the advantage, what's the amount of marks you are going to get by learning this in the exam, right? That's the purpose now, that's the idea now, right? Let's move on. Now we are getting into the thing. Listen, when it comes to electronics, it consists of basically 2 parts. Listen, don't write anything, just look at the board and listen. Right? It consists of 2 parts, right? One is called digital electronics. Right? And the other part is called analog electronics. Right? Digital is only 1/5 of the entire unit. 1/5, around 20% is digital, right? Around 20 කිව්වත් 20 වල තරම් පොඩ්ඩක් අඩුයි. Around 18% is digital and the rest is analog, right? එතකොට තේරෙනවනේ මොකද්ද ලොකු එක කියලා. Digital is around 1/5, right? and 4/5 is for analog. Right? Today my plan is to start digital and we'll try to finish digital by today itself. Right? The content is it's a little bit more than the time we have today, but we'll try to finish digital by today. Right? And basically I'll be covering everything starting from zero in digital with some examples, and we have more other questions from digital in the tute also. Right? I think you haven't received the tutes yet, so we will get the tutes by next week. No, then after tute is received, we will practice more questions. But my plan today is to cover everything in digital today. Right? Inside digital today. Right. First, write down first point. First point. Electronics can be divided. Electronics can be divided. Electronics can be divided. Electronics can be divided into two main categories. 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 Two main categories. Right. Mention this. First one, digital electronics. Second one, analog electronics. Digital and analog. First one, digital electronics. Second one, analog electronics. And today we'll be starting the digital part. Right? Take down. And then as the next subheading, take down digital electronics. First subheading for today. Now before digital, write down the difference between analog and digital electronics. Write down the difference between analog and digital electronics. Next heading, the difference between analog and digital electronics. Difference. The difference between analog and digital electronics. So at the board, this difference is explained using a VD variation. VD means a voltage variation, right? Voltage variation. So at the board, when it comes to digital, if we draw VD, right? In digital, VD varies only in two values. There are reasons for this, right? You will see the reasons in the next parts, right? You will see the reasons for these things in next part. For digital, it varies only in two values. Only in two values, not in between, only in two values, right? It is either 5 or 0. Only two values voltage wise. Only two values voltage wise. As the standard voltage, we will consider 5 volts, right? So that is either 5 or 0 when it comes to digital. Digital, right? And for analog electronics, this voltage variation or the voltage can be varied to any possible value, can be varied to any value, right? Something like this, it can be varied to any value, right? No any restrictions, no any limits, no any limits. It can be varied to any value, right? This is for analog. Right, now today we are going to start the digital part now. So in digital, we'll only have two standard voltages, either 5 and 0, right? 5 is 0, which means we are going to have some binary voltage variables here, right? Binaries. You will see how these binaries are linked to these things in the next part, right? So first, take it down at these two sides like this, and we'll be writing 2 points under each graph, right? So you better divide this into two like this and keep some space behind each graph, below each graph for these points, and take it down quickly. right? And another thing I wanted to remind is that we'll be having our thermal practical seminar tomorrow, right? Like already done on it. So we'll be having our thermal practical seminar tomorrow. Right. So we'll be starting tomorrow at 7th June. Right? We'll be starting at 7 p.m. We'll be starting at 7 p.m. and I'll be physically at Lisa Orana, right? Physically at Lisa Orana, and it will be live on YouTube, right? It will be live on YouTube, and we'll be discussing all the experiments we have in thermal physics, right? All the experiments we have in thermal physics tomorrow, right? So this is actually the fourth practical seminar I'm conducting for your batch, right? Fourth practical seminar. We started from mechanics. I had a practical seminar for mechanics, and then for waves we had one, and then for optics we had one. This is the fourth. Thermal, right? And I'll be doing another one before the exam for electricity as well, right? So this is the fourth one we are going to have tomorrow, right? So I think all of you have seen the flyers and you are ready now. You are ready, right? So when you are joining, it's better if you can go through the practicals and join, because then now before I explain, when you have an idea, maybe a partial idea for maybe some extent up to 50% of the practical, that would be enough, because we are in a period where 9 weeks ahead from the exam, right? 9 weeks and 2 days. We are in a period where you are 9 weeks ahead from the exam. So that's a very small time. Then always, when you engage with these things, the rate that you are going to improve yourself is higher, right? When the rate is higher, then you will get that advantage, that benefit in return in 9 weeks of time. That's the thing, right? Just 9 weeks, So be ready, prepare yourself, and we'll be starting at 7, right? We'll be starting at 7. If you are joining physically, you can come to the institute, Lisa, by 7, right? And if you are joining online, you can join the online one on YouTube, right? Okay, then. It was just another reminder. And actually, I had to postpone the thermal seminar last month because most of you had term test in schools, right? Term test in schools in last month. So therefore, I had to shift it to this month, and we'll be having it tomorrow. Right? Finished? Under digital, write down. Under digital, write down. Under digital, voltage of digital circuits. Voltage of digital circuits can be varied. Voltage in digital circuits can be varied. Voltage in digital circuits can be varied only in two values. The word is very important, right? Not in between, right? Between kyo taradi, right? Not in between, only in two values. Right? So some things that is in between, no, that is not in between. That is either 5 or 0, in two values only, not in between, in two values, right? Voltage of digital circuits can be varied only in two values. Underline, no highlight, in two values. Underline, no highlight, in two values. Underline, no highlight, in two values. Within brackets, write down 0 or 5 volts. 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 within brackets 0 or 5 volts within brackets 0 or 5 volts 0 or 5 volts, right? Under analog side, write down under analog side, write down voltage of analog circuits, voltage of analog circuits, voltage of analog circuits, voltage of analog circuits can be varied, can be varied, can be varied, can be varied, can be varied to any value. Voltage in analog circuits can be varied to any value, can be varied to any value, can be varied to any value. Can be varied to any value, right? Right, now we are going to start our thing for today, right? We are going to start our thing for today. As number 1, heading number 1, write down digital electronics. Heading number 1, digital electronics. Digital electronics. Heading 1, digital electronics. Digital electronics. Digital electronics. Right. Listen now. Listen. Listen. When it comes to digital, right? Digital electronics, right? Here we'll be mainly dealing with two values, two voltage values, as I mentioned before, right? Now, when we have voltages, right? When we have voltages, for these variables in this, there are variables in digital electronics or digital to study digital. It has voltages, and to study digital, we have variables, and those variables are very specific type of a variable, right? Now, if I compare this with the variables you have in simple maths, say you have a variable as x, right? In simple maths, you have a variable as x, right? So if there are no any other special constraints, the limit of this one is varied from minus infinity to plus infinity. No? That is how it is. No? If there is a variable in simple maths, but when it comes to electronics, digital electronics in the sense digital electronics, right? If we have a variable, we have only two values, right? That's the thing here. We have only two values, either 0 or 5, right? Voltage wise. Now, for our mathematical aspects and the logical aspects, we are going to convert these voltage values into logical values, right? So let's see how that is done. And say we have a, as an example, say we have a variable A in digital. If this was a digital variable, it can have only two values, either 0 or 5, right? Such variables are called Boolean variables. Such variables are called Boolean variables, right? Boolean කියලා කිව්වා නම්, which means that is a digital variable. Digital means that is a binary variable. Boolean means binary variables, right? Okay, under digital, as the first point, write down digital first point, write down unknown variables. First point, unknown variables, unknown variables, unknown variables in digital electronics, unknown variables in digital electronics, unknown variables in digital electronics, unknown variables in digital electronics are called Boolean variables, are called Boolean variables. Are called Boolean variables. Boolean are called Boolean variables. Unknown variables in digital electronics, unknown variables in digital electronics are called Boolean variables. Boolean variables. Next point, write down. Boolean variables have, next point, Boolean variables have only two possible Boolean variables have only two possible Boolean variables have only two possible voltage values. Boolean variables can have only two possible voltage values. Boolean variables can have only two possible voltage values. Boolean variables can have only two possible voltage values. Right. Listen. Now this is how it works. Say this A is a Boolean variable. Say this A is a Boolean variable. If A is a Boolean variable, right? If A is a Boolean variable, right? Now it can have only two values, right? Either 0 volts or 5 volts, right? Either 0 volts or 5 volts. And this is voltage wise. Listen, this is voltage wise. These values are voltage wise in terms of voltages, voltage wise, right? Now when we are dealing with the logics here, right? Make a logics here now, you will see the logics in the parts coming up. Then for the logics, we are not going to use these actual values of voltages, but instead we are going to convert this into a logic. Right? When we are converting this to a logical format, listen, logical format, 0 volts is considered as 0 volts is considered as 0, right? And 5 volts is considered as 1, right? They are the logics. Logics means instead of 0, logically we will argue that 0 as 0, and instead of 5, we will treat this 5 as 1, right? And this is called digital wise, right? And these 1 and 0 are called digits here. That's how this term digital comes. They are called digits. 1 and 0, digital digits, right? And this is called digital wise. Right? Digitally, අපි ලියුවොත් ඔක ලියන්නේ normally digital law or logic කියලා කියන්නත් පුළුවන්. Digital law logic. Digital or logic wise. Right? මේ කියන logic එක මොකක්ද කියලා ඉස්සරහට තේරෙයි. Right. So first mention this. Now basic idea that you have to understand here is, right? If we have a Boolean variable in digital, right, it can only have two values for the voltage, either 0 or 5. Logically, we say 0 is 0 and 5 is as 1. Logically, we consider it as 0 and 1. Logically. Logic එකක් විතරක්. Right. Take down. Right. So voltage wise we have 0 and 5, and logic wise digital wise we have 0 and 1. Right? So when we have two values, we call it a binary, no? When we have two values, only two values, we call it a binary. Right? So therefore, this is also binary. This is called a binary variable. Boolean variables are binary variables. Binaries. Right? අපි binaries කියන්නේ දෙකක් විතරක් තියෙනවාට. Bi means two, no? Binaries. Right. Then next thing, then variables දන්නවා. Next thing is for Boolean, for Boolean, we have functions. Right? Then write down as a next heading Boolean Boolean slash digital functions. Right. Boolean slash digital functions. Boolean slash digital functions. Listen. Listen now. Functions are like this. Right. Now I'm comparing this with normal maths or simple maths because to you to compare this. That's why. Right. Now in maths, we have functions like addition, multiplication, integration, differentiation. Those are mathematical functions. No? So likewise, here we are going to have digital functions or Boolean functions, right? Then that function is going to do some simplification with these Boolean variables, right? Something like that, right? We have three main functions in digital. We have three main functions. Three main, na? There are more functions, only three main functions. First function is called O function. Listen, don't write anything. First function is called O function, right? And it is denoted by plus. This is only a symbol. That doesn't mean that is going to add, right? That doesn't mean that is going to add. That is a symbol. It is symbolized by plus O, right? O means now when we are going to connect variables, right? When you are going to connect variables, right? O is going to use as a connector, as a function for connecting. Again, example is like, now meaning of O is the literal meaning of O, right? O means O. O means O, right? O meaning meaning. You are going to connect this, you are going to use this to connect two variables like this. As an example, say we need to say A, O, B somewhere, right? You need to say A, O, B somewhere. You need to say A, O, B somewhere. A, O, B, right? Digitally, I can represent this as digitally I can represent this as A plus B, right? We say there is plus, that's a plus sign, but doesn't mean there is addition. Addition, it means O, right? And the second function is, don't write. Look at here, these are the basics. These are the basics. Second function is AND, AND, AND. And the literal meaning of AND is here, right? AND is denoted by a dot. AND is denoted by a dot, right? Now, as an example, if I use AND function, to write two variables, it is like this. Say I need to give somewhere as A and B. This can be written as A dot B. This can be written as A dot B, right? Sometimes without writing the dot, this is also written as AB, right? Dot because if there's nothing in between, that is dot. Functions to anything. Then the other function is called the complement. Other function is called the complement. Complement function. Listen. Complement. Complement is denoted by bar. Complement is denoted by bar. Like this. Denoted by bar. Right? Which means it is something like this. Example. Say I need to say complement of A. Right? My complement of A. Complement of A. Complement of A. That is denoted by A bar. That is denoted by A bar. Right? Complement means, now even though O and N has a literal meaning, sometimes you might not get the word complement. Sometimes. Complement means, now this variable can have only two values, no? Right? Either 0 or 5. Or logically 1 or 0. Complement means, when the present value is 1, complement is 0. When the present value is 0, complement is 1, which means, right? Which means the other value compared to the present value is called the complement, right? Now, as an example, if I further explain, complement is like this, right? Complement is like this. Complement of 1 is 0. Complement of 1 is 0. Values so very easy. Complement of 0 is 1. Right? Complement means always that is the other value compared to the present value. Right? compared to the present value, right? ඒ කියන්නේ not කියන්නේ දැන් තියෙන value එක නෙමෙයි අනිත් value එක කියන idea එක complement the other value values එකනේ තියෙන්නේ, right? These three are the three main functions, O and complement, right? And these functions are the logics we have in digital. Functions means logics, right? ඒ කියන්නේ now say I need to say A or B. Digital meaning is here either A or B or digital meaning here. And the actual meaning here is, right, for a voltage of 5 volts, another voltage of 5 volts is going to be connected, right? 5 or 5 වගේ එකක් තමයි logical meaning එක එන්නේ, 5 or 5. And then if A and B are connected together, right, again if this is 5 and 5, what if A plus B, what if A or B, then what is going to happen in the third side means the other output, something like that, right? තාම තේරෙන එකක් නැහැ කියන්නේ මොනවද කියලා, right? You will see in a very short while, right? මුලින්ම මේක ලියාගන්න, right? Now you can take down O and complement. These three are the three functions, right? So far what you need to understand is we have Boolean variables in digital, right? Boolean variables has only two values, 0 or 5 voltage wise and 1 or 0 digital wise, right? And to simplify these variables we have three functions as O and complement, right? Take it down. That's it for now. Right? Right. Listen now. Now, as the next heading, write down Boolean simplifications. Next heading, Boolean simplifications. Boolean simplifications. Boolean simplifications. Boolean simplifications. Right. Listen now. Listen. Right. For the simplifications, I'll be using a table like this. For these simplifications, we'll be using a table like this. Right. Say we have a Boolean variable here as A. Right. This is the same variable. And here we'll be writing A plus A. Right. And here you will be writing A dot A. And here, listen. A plus A bar, right? And A dot A bar, right? For a Boolean variable, we have only two values. For a Boolean variable, we have only two values, right? Then it can be either 0 or 1 digitally. Then A can be either 0 or 1, can be either 0 or 1, right? Now this is what we are going to do, right? Stop all your work and look at here. Stop all your work and look at here. These are very simple thing to understand. And from electronics also, digital is the most simplest part we have compared to analog, right? Okay, a plus a means, right? A plus a means it is now for this line it is like 0 plus 0, right? It is like 0 plus 0. It is like 0 plus 0, right? 0 plus 0. 0 plus 0 means now the actual meaning here is, right? Actual meaning here is for a wire, right? It doesn't has a current, right? Another wire, it doesn't has a current, is connected together, right? Current එකක් නැති wire එකට current එකක් නැති wire එකක් connect කරා වගේ. Logic එක මම මේ කියන්නේ. Logic is like that. If you connect a wire with no current with another wire with no current, there won't be a current in the other wire also, no? In the third wire also, no? Right? So therefore 0 plus 0 is logically 0. මෙහෙම තමයි මේක simplify වෙන්නේ. 0 plus 0 is 0, right? Which means, right, voltage වලින් කියන්නත් පුළුවන්, current වලින් කියන්නත් පුළුවන්, right? If there's no voltage, right, in both wires, there won't be any voltage in the third wire also. If there's no current in two wires, there won't be a current in the third wire also, right? ඕක තමයි logic එක මෙතන. That's a logic. So likewise, logically argue. And if I do it here, see, 1 plus 1 means 1 or 1, right? Current flows वगैरह. Current flows is connected with another current flowing wire, then a current flows definitely, then 1, right? Now when we do these simplifications, right, podi tawa hint එකකුත් දෙන්නම් අහගන්න. When you do these simplifications, this is a hint. When you do these simplifications, right, you will see the behavior of this O function as, you will see the behavior of the O function as addition, right? But that doesn't mean there is an addition. 1 plus 1 2 unne. 1 plus 1 is 1. 1 plus 1 is not 2. So that is not an addition, but it has the behavior of addition. Podi behavior එකක් තියෙනවා, right? And when it comes to dot function, right, you will see it will have kind of a behavior of multiplication, but that is not multiplication. You will see some sort of a behavior. 100% multiplication එකක් වගේ නෙමෙයි, but you will see some sort of a behavior with multiplication, right? Okay, now take it down and try to complete the rest of the cages here. Listen carefully. Try to complete the rest of the cages here, and these blanks here, මේවත් ඕනේ. A plus A dot A plus A bar, A dot A bar. මේවටත් මට answers ඕනේ, right? Then 1 2 3 4 5 6 cages, and here 1 2 3 4 10 blanks already. 10 blanks, right? Take it down and give it a try quickly. Right, now for this line, what you are getting is 0.0 for this line, for this cage 0.0. For this cage 1.1, and for this cage A, when A is 0, A bar complement. Complement means the other value, no? A bar is 1, then 0 plus 1. This is 1 plus 0, right? And this is 0.1, 1.0. right? See, 0.0, right? Our hint and these AND connections are like series connections. And again, they are like series. And means when one is completed, only the other one can be done. And this one and this one, okay, again, either one of those, right? Parallel wage. They behave as parallel. They behave as parallel. Right? First one, 0.0, right? If you connect a wire with no current, right, to a wire with no current flows, right? No current flows, 0. 1.1, 1, right? 0 plus 1, 0 plus 1, 0 plus 1, 0 plus 1, 1. 1 plus 0, 1. 0.1, 0.1, 0. 0.1, 0. Right? If you don't have a current in one wire, right, then you are not going to have the current in the third wire. 1.0, 0. 1.0, 0. Right? Now, using these results, we are going to answer these ones also. Fill these ones also. A plus A dot A plus A bar. Make fill කරන්න ඕනේ. ඒවා එකක් fill කරන්න මෙහෙමයි. Right. මම එකක් කියලා දෙන්නම්. Say you need to fill A plus A bar. Right. See, you are going to fill A plus A bar. A plus A bar නෙවෙයි, A plus A. You are going to fill A plus A. Right? See what is happening? Now it has only two variables, either 0 or 1. When A becomes 0, right, it is 0 plus 1 and it has become 0. When A becomes 1, right, it is 1 plus 1 and it is 1. 1 plus 1 and it is 1. It is 1. Right? Now, when you have 0 here, the answer is also 0. 0 plus 0 is 0. When you have 1 here, the answer here is 1. Then if you have A here, answer should be A, no? 0 tibbot 0 enne. 1 tibbot 1 enne. If A is as A, then this should be A. Right? So that's how we simplify it here in that Boolean form. Right? A plus A is not 2A, that is A. A plus A means A. Right? මේක කරන්නත් එහෙමයි. පොඩි pattern එකක් තියෙන්නේ. Identify this pattern. Understand the pattern. A dot A. Right? A dot A, no? Right. It can be either 0 or 1. When A is 0, 0.0 becomes 0. When A is 1, 1.1 becomes 1. Right? Then if A is A, A dot A should be A. A dot A should be A. Then this is A. Got it? So likewise, fill all of them. Now the advantage means the easiness we have in digital is easiness, right? Or the convenience we have in digital is we have only two values now. If you check for both values, which means all the values are checked off. If you check for two values here, just two values here, all the values are checked off, right? Then this equation or the expression is either going to be 0 or 1 when A equals 0 or equals 1, which means all possibilities are here. Values දෙකනේ තියෙන්නේ. That's the simplicity we have here. That's the simplicity, right? Then when it comes to something like this, right? මේ වගේ අපට special නේ, but we have only two possibilities. When A is 0, this expression has been 1, right? When A is 1, that is again 1, right? Then in both possibilities, that is 1, right? The world of a Boolean expression is binary. Then when A is 0 also, this is 1. When A is 1 also, this is 1, which means forever this is going to be 1. Right? Forever this is 1. Then this is always 1. Right? So similarly, forever this is 0. Forever that is 0. Got it? Variables දෙකටම එකම නම් එන්නේ. If you get the same value for both variables, which means forever that is going to be that same value. Right? If it changes accordingly, then you have to check the pattern. and write it here, right? Pattern එකක් අතරම මේ තියෙන්නේ. That's a logic, right? Change වෙනවා නම් pattern එක check කරන්න, right? If it has no change, which means the constant value here is going to be 1. That's the constant value, the forever value, lasting value, right? Fill it accordingly. And after this, I will give you some simplifications to do by your own, right? We'll see some simplifications to do by your own after this. Right, for the simplifications, if you assume that as a behavior of addition or multiplication, that is fine, but that's only a behavior in some places. That may behavior a dot a, right? That is not a squared, no. If that is not 0, that is a, something like that, right? Multiplication that is not a multiplication, only a behavior. Behavior පොඩ්ඩක් තියෙනවා, right? ඒ නිසා මේ multiplication කියලා මේ හිතා ඉන්න එපා, right? Multiplication කියලා හිතන් ඉඳලා හැම එකම simplify කරන්න බෑ. That is not a multiplication, that is n function. ඒ තියෙන n function එක. A and A is A again, right? A and A is A again. A or A is A again, right? Something like that. Okay, finish. Now, I will give you some example simplifications, right? You have to simplify these ones one by one, right? Simplify and put the values, right? First one, right? මම එහෙම expressions ටික දෙන්නම්, you can simplify. Right, you can simplify. Start simplifying. Right. Start now. Start now. And if you have any doubts, any questions from the things we have discussed so far, right? You can ask if anything. You can ask if anything, right? So I will start the discussion of these answers in like 3 minutes. So now we are able to do 9A. Yeah, you can do. Until what time? Not sure. You mean in two values? In two values, not in between. Should we need to show the work in the tables? No, no need. Should we use the data in the table? Data in the table. I didn't get your question. Data in the table means? Can you explain A dot A plus A bar and A dot A bar again? A dot A. A dot A means from pattern again got it, right? I found the answer using pattern because in the table you had 0.0 and 1.1. When A becomes 0, answer is 0. When A becomes 1, answer is 1. Then if A is as A, answer should be A. Right? For A plus A bar and A dot A bar, again the explanation is in the table. Explanation is in the table. Right? When A becomes 0, this answer is 1. When A becomes 1 also, this is also 1. Right? Which means forever this is going to be 1. Always there is 1. Forever means always there is 1. Right? So in this case, the opposite. Right? Always there is going to be 0 if when you check for both variables, if you get a same value. Right? Which means you have checked for all possibilities, no? You have checked for all possibilities. When you check for all possibilities, if you are getting the same value, which means always there is the same value you are going to get. Right? Now here also when you simplify something, any variable I have given here, maybe A, B, ABC, BC, anything, right, is going to have either 1 or 0 at the end of the day. Boolean. Boolean කියන්නේ ඒක, right? මං කොච්චර ලොකු expression එකක් දුන්නත්, even if I give A plus AB plus ABC, that whole expression is going to have 1 or 0 at the end of the day. Right? So when you argue also, argue that way. Right? That is where the exact concept behind digital here. නැත්නම් මේක පාඩම් කරගෙන කරන්න පුළුවන්. Right? මේක පාඩම් කරලා කරන්න පුළුවන්. But understand the concept. Right? Physics means concepts. No? Concepts. I mean for the values of A. This is an example I used. Example I gave. So all the answers in this will be 0. No. There can be this kind of ones also. A plus A is A. Right, shall I check? Shall I check? We have a birthday party in our home today, right? But I didn't go to even a photograph uh, because of this, right? මේ කට්ටිය මට ගත්ත photos දානවා. Right, අපි ඒක බලවද හිටියේ. කට්ටිය photos ආයෙත් මට දානවා. මේ right. birthday party එකක් කියලා ඉතින් යන්න බෑ. වන්නේ class එක කරන්න ඕනේ. Okay, finish. So you value us so that no, not to my, not my friends. Friends නෙමෙයි. One of our grandmas. මේ අපේ ගෙදර තියෙන්නේ. That is here. Now I'm in home today, right? මේ මං home studio එකේ ඉන්නේ. මෙහෙ තියෙන්නේ. Here. Grandmas. One of the grandmas. Friend's birthday එකක් නෙමෙයි. Okay, finish. Let's see. Right, see? 0 plus 0. 0 plus 0. 0. Right? 0 plus 0. 0. 0 plus 1. 1. 1 plus 0. 1. 1 plus 1. 1. 0 dot 0. 0. 0 dot 1. 0. 1 dot 0. 0. 1 dot 1. 1. Right? 1 plus a. What about 1 plus a? 1 plus a. Right? If you have a variable, right? One way that you can check it out is, right? There are only two possibilities that a can take. No, මෙතන variable එක a නේ. One is a definite value. One is a definite value. That's a definite digit. But a is a variable. Right? එහෙම case එකක් check කරගන්න ඕන check කරන්න මෙහෙමයි. Right? මේකත් බලන්න. Say you need to check 1 plus a. Check කරන්න මෙහෙමයි. Right? A can either take 1 or 0. A can either take 1 or 0. When a is 0, this expression becomes 1 plus 0. No? When a is 0, if a is 1, this expression becomes 1 plus 1. 1 plus 0 is 1. 1 plus 1 is also 1. Which means this expression is always going to be 1. Then 1 plus a is 1. Take a check කරන්න ඒ විදියට. Got my point? Raise your hand if you understood this one. Raise your hand if you understood. හරි. වැඩේ clear නේ? එහෙම එකක් check කරගන්න ඕන check කරලා බලන්න ඕනේ. check කරගන්න ඕන check කරලා බලන්න පුළුවන් මෙහෙම. Right, if it changes as 0 and 1 then write the pattern. 0 and 1 change වෙනවා නම් write the pattern using A or B C or whatever it is. Right, then 1 plus A වගේ එකක් check කරමු. See 1 plus A මේක check කරන්න මෙහෙමයි. Look at the board. If you need to check this out, 1 plus A, right, only variable here is A, only variable here is A. Then when A takes 1, sorry, when A takes 0, this becomes 1.0. Right, when A takes 1, this expression becomes 1.1. Then A dot 1.0 is 0, 1.1 is 1. Right, අන්න දැන් ඒක change වුණා. අන්න change වුණා. Right, when A is 0 මේ පාට pattern එක. When A is 0, answer is 0. When A is 1, answer is 1. Then if A is as A, answer should be A. Then 1.A is A. 1.A is A. Right, අර multiplication එකක් වගේ එකක් තියෙනවා කියලා මම කිව්වේ ඒකයි. 1.A is A. හැබැයි logic එක තියෙන්නේ මෙතන. Logic is this, but it has some kind of a behavior as multiplication. 1 times A වගේ නිකන්. Right, it looks like. Right, looks like. 1.A is A. What about 1 plus A bar? Anyone? 1 plus A bar. Tell me the answers. 1 plus A bar. 1 plus A bar. Right, again the same thing. A bar is going to have either 0 or 1 at the end. Either 0 or 1. Right, 1 plus 0, 1 plus 1 is always 1. That is 1. Right, 1 dot A bar. A bar. 1 dot A bar is A bar. Right, A plus A bar 1. That is proved. A dot A bar 0. A plus A double bar. What is A double actually? A double bar means complement of A. Complement of A. A double bar. Complement of A. Right, එතකොට තේරෙනවද? Complement of 1 is 0, then complement of 0 is 1 again. Right, ඒ කියන්නේ කොහොමද වෙන්නේ? Then A double bar is always equivalent to A. Complement of A. Complement of A. Right, if A is 0, A bar is 1, then its bar again is 0. Again A ne ආයි ඇවිල්ලා තියෙන original A is coming. Right, so it is like A plus A. It is like A plus A. A plus A means A. Right, this one A dot A double bar. It is like A dot A. A. 1 plus A double bar. Right, A double bar is again going to have 0 or 1 at the end. Answer is 1. Right, this one A bar plus A plus 1. A bar plus A plus 1. A bar plus A means 1 no. මේක අපි දැන් prove කරානේ. A bar plus A is 1. 1 නේ. A plus A bar 1. ඒ කියන්නේ මේ අතර මොකක්ද තියෙන්නේ? This is 1 plus 1. 1 plus 1 means 1. Right, then AB plus 1. Again AB is an expression. As a whole expression, AB is finally going to have either 0 or 1. Then 0 plus 1 is 1, 1 plus 1 is also 1, then AB plus 1 is always going to be 1. AB plus 1 is always going to be 1. It's always going to be 1. Right, try last 4 also, last 5. Try last 5 also. Right, Listen, for an expression like this, a plus ab, right? If we have common variables, right, we can take them out as we do in our normal maths, right? Common variables can take out. Common variables can be taken out. See, a is a common variable. Now, this expression can be written as a, right? 1 plus b. It can be written as a 1 plus b, right? 1 plus b is 1. ඒ වගේ එකක් මෙතන සිම්ප්ලිෆයි කරා. මේ තියෙන 1 plus a is 1. So likewise 1 plus b is also 1. 1 plus b is also 1. 1 plus b is also 1. Right? Which means, right, the expression is here is a dot 1. A dot 1. A dot 1 is like 1 dot a. 1 dot a is a. It is a. Right? So the final answer here is a. Final answer here is a. I'm going to erase this part since we might need some space for the rest coming now. Right? A dot B. What is happening? A dot B. A dot B. Right? A dot A is known, no? A dot A. A dot A is known. A dot A is A. Right? A dot A is A. Right? Then this is A. Finally, that is A dot B. This cannot be simplified further. A dot B, that's it. This cannot be simplified further. A dot B. Right? A plus A bar plus B. Right. Make a number method simplify. A plus A bar plus B. A plus A bar is known. A plus A bar is 1. Right? 1 plus B. 1 plus B is 1. 1 plus B is 1. Right? Next one, AB plus BC plus 1. AB plus BC plus 1. Right? Now, as an expression, listen, as an expression, this whole expression is going to take either 1 or 0 at the end of the day. Right? 1 by 1 check karanda. This whole expression is going to take either 1 or 0 at the end of the day. Right? Either 1 or 0 at the end. Right? Even though there is 0 or 1, always the answer is 1, which means this is always going to be 1. Right? This is always going to be 1. That is always going to be 1. Then this one, A plus AB plus ABC. A plus AB plus ABC. A plus AB plus ABC. Right? Now for this, A is common, no? If A is taken out, 1 plus B plus BC. Right? So again, something similar. See, B plus BC is going to take either 0 or 1 at the end. Then 1 plus this part is, even though there is 0 or 1, there is always 1. Which means this bracket is going to be 1 always. Then what is hidden here is A dot 1. Right? So finally, that is A. That is A. That is A. Right? Right. Since we have come to the end of all 25, right? You can ask if any questions before moving on to the next part. You will get some more simplifications in the tut also, right? You will get some more simplifications in the tut also. Right. Any questions before moving on? Any questions before moving on? Can you show the work info? 15. 15. A plus A double bar. A double bar is A, no? then this is A plus A. A plus A equals A. A double Y is A. Complement of complement. Complement of complement. A double bar means again it is coming to the original value. A double bar is again coming to the original value. But 1 0 दाल check करा. Apply 1 0 and check it out. Right, no other questions. Raise your hand if you have understood everything up to this point. Raise your hand if you have understood everything up to this point. 3, 4, 5, 6. How many? How many? Quickly. Right, majority is there. Right, let's move on. Let's move on. Now, from these simplifications, I'm going to extract some special things. See, from these simplifications we did, we can extract these things. Right? We can extract these things. Right? First one is about A double bar. A double bar is A. Right? And second one is 1 plus any. 1 plus any. May one check 1 plus any is going to be 1 at the end. Right? Because any means any expression is going to take either 1 or 0. No? Then 1 plus any is always 1. Right? So similarly, 0 dot any is always 0. Right? Mention these points in a red pen. Right? I extracted these things from these simplifications we did. Right? Extracted these things out from the simplifications we did. Right? Mention them in right. Any means any variable, any expression. Any means that any variable, any expression. Any variable, any expression. Right? Any variable, any expression. Are you still confusing with A double bar? Something like this. A bar, A double bar. Right? If A is 0, A bar is complement of A is 1. No? Right? Now, A double bar means complement of A. Again, मेरे complement है क्या? Complement of A bar is 0 again. Right? Then if A is 1, complement of A is 0. Then complement of A bar, maybe a complement of A bar, maybe a complement of A. This is complement of A bar. Right? A का मैंने complement of A किया. Right? maybe a complement of A bar. Right? The A bar के complement A bar again then 0 1. Right? It is coming to the original value of A again. Then A double bar is A. A double bar is A. Clear enough? Right. Now, moving on. Right. Moving on. Right. As the next heading, write down splitting a bar. Splitting a bar. Splitting a bar. Complement के लिए splitting a complement. Bar के लिए complement. Splitting a complement. Splitting a complement. Right. For this we have a rule. Right. This is a rule. Right. This is called De Morgan's rule. Right. We don't have the proof of the rule. We'll be using the rule. Right. If you are doing combined maths and if you have already done probability in combined maths, you know this. Right. Combined maths probability then कर लेते. Right. Then you should know De Morgan's rule or De Morgan's law. Right. मैं use कराने ते कम तमाई. De Morgan's law. Right. De Morgan's law के use करना है बार. Then using De Morgan's law, bars can be split as now. Say you need to split A plus B whole thing complement. Right. This is written as A bar dot B bar. Right. and A dot B whole complement is written as A bar plus B bar. Right? අපි De Morgan's law එක prove කරගෙන ඉන්න we'll be using the results. Right? ඒක physics වල වැඩ නැති නම් මේක prove කරන්න. පාඩ prove කරන්න ඕන නම් physics විදියට prove කරන්න ඕන නම් මම කියන්නම් ඕන විදිය. You can have a truth table, right? Truth table සම ඉස්සරහට කියලා දෙනවා. You can have a truth table and check how it works. Right? Okay, take it down now. Splitting a bar. Take it down. Take it down. Right? And the other thing, right? Then simplifications කරලා ඉවර නිසා මම කියන්න. Listen. Digital variables always has an aspect coming from sets, right? Sets වලින් එන aspect එකක් තියෙනවා. In sets you have two functions as union and intersect, no? Right? Sets කරලා තියෙන union and intersect, right? Plus function here in digital is proportional to union. Plus means union, right? And dot is proportional to intersect, right? And complement of set ඒ වගේ ඒවා තියෙනවනේ complements මේ sets වල. complement කියන්නේ complement ම තමයි. Got it? Right? එතකොට මේක sets වලින් ඕන නම් කියන්නත් පුළුවන්. Right? If you know sets, right? Sets වලින් කියන්නත් පුළුවන්. This is like A union B sorry කොහොමද ඒ කියන්නේ? A union B no, it's like this. මම ලියලා පෙන්නන්නම්. If you have something like this, A union B by කොහොමද ලියන්නේ මේක? මෙන්න මේකනේ. මෙහෙම ලියන්න. This one. Right? මේක ලියන්න මෙහෙමයි sets වලින්. Right? ඔය පොඩි ගාලා ලියලා තියෙන O levels වල මේක ලියලා ඇති. sets වලින් ලියන්න මෙහෙමයි. මේකම තමයි මේ තියෙන්නේ. Right? ඒ කියන්නේ මේක ලියන්න පුළුවන් කියලා කියන්නේ මෙහෙම. This can be written as this and this can be written as මේක O levels වල කරලා ඇති. This. Right? මෙහෙම sorry. unknown එක. ඕමයක් O levels වල කරලා ඇති. That same result, right? That is coming from De Morgan's rule, De Morgan's law, right? ඒක තමයි මේ කිව්වේ. right? sets එක ඔක connect කරගන්න ඉතින්. එතකොට තව lazy. sets එක මේක connect කරනවා තව lazy. right? digital කියන්නේ ඇත්තටම sets. okay. හරිනේ මේ දෙයක් හරිනේ. right now let's see another example simplification before moving on, and you will get more simplifications on the route. right? You will get more simplifications on the route. right? ඊට කලින් අපි තව එක simplification එකක් වගේ කරලා යමු. try this as an example. right? example boolean simplification එකක් කරන්න හදන්නේ. right? Right, this one. First give it a try. Right, may bars same good at now if you are applying this, right, always that is applicable to the variables which are inside your splitting bar. And this is not only limited to two variables. Make say you need to split a plus b plus c bar, that is a bar dot b bar dot c bar. So likewise, they are valid for any number of variables. Before I simplify, give this a try. Like 2 minutes. Any answers? And when you simplify a Boolean expression, right, there can be multiple ways of simplifying it, right? Doesn't matter, right? There can be multiple ways of simplifying it. Unless you do an improper or wrong simplification, you will get the correct answer, right? As long as your simplifications are perfect and proper simplifications, valid simplifications, right? Even though your method is different, final answer would be same. It should be same, right? ඒක වෙනස් වෙන්නේ නැහැ කොහොම කරත්. Any answers before I start? Zero. Possible. Let's see. Right. Since we are getting answers, we'll start. Right. So first of all, before splitting any bars, I can say A is common here. No? I'm going to take it out. Right. This is what I see. Right. Only there I'm going to take A out from this. Right. If A is out from here, right? If A is out from here inside the bracket, 1 plus B plus BC remains, and we have another A here plus A bar, this bracket, and from this one I can see B is common, take it out, then 1 plus C remains. 1 plus C remains. This bar is still remains the same. 1 plus anything is 1, no? Right? Then column proofs use karan. 1 plus anything is 1. Then this is 1. Right? 1 plus anything is 1. This is also 1. Right? And මේකත් simplify කරමු. This is මම ඔන්න පෙළියක් ලියන්න. කවන්න මම line එක ලියන්න. This is A dot 1 dot A plus A bar. Right? Brackets. This is 1 B dot 1 B dot 1 bar and a whole bar. Right? මේක simplify කරන්න පුළුවන්. A dot A is A. Right? අපි කලින් simplify කරා A dot A is A. Then A dot 1 is A again. Then this is A plus A bar. Right? So what you have here is A plus A bar. A plus A bar in this square bracket. Right? And B dot 1 is B, no? This is B bar. And a whole bar. And a whole bar. Right? Then A plus A bar is a known one, that is 1. Right? 1 dot B bar whole bar. 1 dot B bar whole bar. Right? 1 dot B bar is B bar. Right? We have another bar here, B double bar. B double bar means B. Final answer, B. Right? So likewise, you have to simplify this properly. Right? අර කලින් කරපු simplifications ඔක්කොම ටික මෙතෙන්ට apply. Apply accordingly. Right? Final answer is B. Final answer is B. Right? So they are called Boolean simplifications. They are called Boolean simplifications. Take it down. Right, finish. What is the rule for 1.10? Nothing such. Because 1.0 is 0, 1.1 is 1, it changes. Right, finish. All clear? Right, we are going to move on. Next heading, truth tables. Truth tables. Next heading, truth tables. Truth tables. Right. So under that, write down. Truth tables are used to. Write down. Truth tables are used to. Truth tables are used to. Truth tables are used to show all possibilities. Truth tables are used to show all possibilities. Truth tables are used to show all possibilities. Show all possibilities of a Boolean expression. To show all possibilities of a Boolean expression. All possibilities of a Boolean expression slash digital circuit. Boolean expression slash digital circuit. Circuits. Digital circuits. Right. Next point mentioned in red. Next point mentioned in red. Next point mention it in red. Mention in red. If there are simple n number of inputs, if there are simple n number of input variables if there are simple n number of input variables, if there are simple n number of input variables, if there are simple n number of input variables, number of possibilities exist is number of possibilities exist is 2 to the power n. Number of possibilities exist is 2 to the power n. If there are n input variables, number of possibilities exist are 2 to the power n. Right now, as an example, it is like this. Listen, look at the board. Say we have two input variables in a truth table. You have two input variables as A and B, right? And we denote output by F. Usually, we denote output by F, right? Now, if there are two inputs, material inputs, then these are the input variables, right? Inputs, and F is the output. Number of possibilities are 2 to the power n. Now, how many inputs? Two inputs, A and B, two inputs. Then possibilities 2 to the power 2, 4. Then you are going to have 4 possibilities. Make apply करना है. Therefore, number of possibilities equals 2 to the power 2 equals 4, right? Which means you are going to have 4 possibilities here in this table. 4 possibilities, right? 4 possibilities in this table, right? And when we fill the table, there's another standard. Listen, when we fill the table, there's another standard, right? Always you have to start from the most left column, right? You have to start from the most left column, and you have to start from a 0. You have to start from a 0. And if there are 4 possibilities, right? If there are 4 possibilities, right? You have to change the first column, digit of the first column, right? With the half value of this one. Now, half of 4 is 2, no? Then this digit is changed 2 by 2, like this. And when you go to the adjacent column, right? Here the digit should be changed with the half value. You change it here. Then mum make 2 by 2 change kare. Make change kare 1 by 1. 0 1 0 1. Then automatically you are going to get all possibilities onto the table, right? You don't need to think about these possibilities and do this, right? That's why this standard pattern is introduced. Start from 0 and change the first column. Change the first column with the half value of this, right? 2 by 2. Then all adjacent columns by the half value, right? Half value you change it here, right? Change as an example, take it down, and I will give you another example table for you to fill up, right? F fill karanna ba, because to fill F we have to know the output expression. Unless the expression is given, we can't fill F, right? Ab expression එක දීලා ඊළඟ එකක් fill කරලා බලමු, right? First fill this table, right? Make a copy down කරගන්න. After copying down, right, as another example, you can try this. As another example, you can try this after that one. right? How many possibilities in the second table? How many possibilities in the second table? Finished? Right. These are the inputs. A, B, C are inputs. Then number of possibilities is 2 to the power number of inputs 3. Right. Then you have 8 possibilities. You have 8 possibilities. Then divide this to 8 rows and fill up. Right. Starting from 0, and when this is 8, change the first column 4 by 4. Second column, half value of this one. This is a standard. Make එකක් හරි වෙනස් වුණොත් truth table එක වැරදි. Right. Then half of this 1 by 1. And another verification you can have if your truth table is correct is that when you fill the truth table properly, always first row is going to be a 0 row and last row is going to be a 1 row. Right, row with 1, last row is row with 0. Right, and now if expression is given for f, right, apni expression එකක් දාගමු. මේක simplify කරන්නත් පුළුවන්. Say f equals a bar plus b plus c, right? Then මේක simplify කරන්නත් පුළුවන්. Say this is now given as a bar plus b plus c, right? දැන් ඕන ඒක simplify කරලා මෙතනින් දාන්න පුළුවන්. That is the final output, simplification of the expression. Right, ඒකත් දාන්න a bar plus b plus c. Right, now for these four, a is 0 කියලා කියන්නේ a bar is 1 no, 1 plus anything is 1. එහෙනම් මේ ටික දෙන්නේ 1 1 1 1 1. Right, and here when a bar is 1, sorry, when a is 1, a bar is 0, right? Then 0 plus 0 plus 0 again 0. Right, අනිත් හැම එකේ 1 ඒවා තියෙනවනේ 1 1 1. Is it? Right, මේ values මේකට දාලා simplify කරලා තියෙන්නේ මේ. Right, මේ ABC වල values මේකට දාලා simplify කරන්න. Right, so that's the basic purpose behind a truth table, showing all possibilities, right? Showcasing, showing all possibilities. Okay, finished. Raise your hand if it is clear enough up to this point, quickly, before moving on to the next part. Clear, right? Okay, good. Let's move on. Next heading, logic gates. Logic gates. Right. Logic gates are a tool right? That's a tool for graphical representation we have for these expressions, right? Using and or complement functions. Graphical representation. Graphically මේක පෙන්වන්න ලේසි වෙන්න. Right? Circuit එකක් වගේ මේක අඳින්න පුළුවන් වෙන්න. To draw this as a circuit when an expression is given, we have logic gates, right? So as the word says, there is only the logic gate. The logic gate එක කියන එකේ තියෙන logic එක විතරයි, right? That is not a circuit. That's a logical circuit. Logic gate. Logic එක විතරයි තියෙන්නේ, right? Now if this happens, something like that. Logic එක. Right? Let's see. We'll do this on a table. You can split your page into 3 columns. Split your page into 3 columns. Split your page into 3 columns like this. First one, name, right? And the second column, truth table. And the last column, analog circuit. Analog circuit. Have a table. Right? First one, name of the gate. Right? Here, truth table. And here, analog circuit. Right? So let's see one by one. First one, O gate. Capital O R O. So we know function of O is plus 2. Right? This is the symbol here. Make a symbol here to represent this graphically. Right? This is a symbol. If A and B inputs to the gate, right? If A and B inputs to the gate, right? The output is going to be A plus B. Graphical representation. Right? Then as the truth table, you have to complete this. Complete the truth table. Variables are A and B. Then you will get 4 possibilities. Variables are A and B. Then you will have 4 possibilities. Right? A, B. Now F is A plus B. Output equals A plus B. Right? Then 0, 0, 1, 1, 0, 1, 0, 1. Fill this. And analog circuit means, right? Listen and give it a try. Analog circuit means consider A and B as switches. Right? We are going to consider A and B as switches and output as a bulb. And you are going to represent this function. Represent this represent the function of this gate or gate using our analog electronic instruments. Analog electronic instruments switches and bulbs and batteries. Switches, bulbs and batteries. Right? ඔය ටික set කරලා මේ function එක පෙන්වන්න තමයි analog circuit එක අඳින්නේ. Right? Use your current electricity knowledge for that. Right? Give it a try. Right? Truth table එකට අකලා fill කරන්න පුළුවන්. Analog circuit එක try එකක් දෙන්න. I will start in a very short while. Right, see, truth table is 0 plus 0, 0, 0 plus 1 is 1, 1, 1. Right, analog circuit using switches and bulbs, right? Now the idea here is this, right? Now idea of O gate is logic right? Logic of O is this, right? Read out logic of O is this, right? O means when A or B is 1, when A or B is 1, output should be 1. When A or B is 1, either of A or B is 1, output is 1. O function. That's a logic. When A or B is 1, output is 1. right? That's a digital logic. අන්නේ logic එක එන්න තමයි circuit එක අඳින්න ඕනේ. right? ඒක නිකන් හිතලා අඳින්න තියෙන්නේ. See, now to show the output we are using a bulb, and for the switches we are using variables AB. See what happens now? Switch off means 0, right? Switch off කියලා ගන්න අපි 0 එක default, right? Switch off means 0. If both switches are off, no no path to pass the current, bulb is not lighting up, 0, right? If B is on, current passes through B and bulb lights up 1, satisfies. If A is 1, current passes through A, bulb is lighting up, satisfies, bulb lights up. And 1 and 1 means both are on, then current passes from both and bulb is lighting up 1. So likewise, to satisfy this truth table, you have to draw an analog circuit. That is called the analog circuit, right? And then after this you can separate this like this and go to the next one. Second one, AND gate, A and D AND. We are using only capital letters for the gates, and symbol of AND is this, right? A, B, F, A dot B, right? Now you can complete them. Now you know what to do. Right? 0.0, 0, 0.1, 0, 0, 1. Right? The logical idea here is when A and B is 1. A and B 1 වුණොත් තමයි දැන් වෙන්න යන්නේ logic එක. When A and B is 1, output is 1. Right? When A and B is 1. Right? මේ බලන්න වෙලා තියෙන්නේ. If A and B both are 1 only, this is 1. That is called AND. ඕක තමයි අර ඇත්තම logic එක. Right? Logic එක. When A and B is 1, output is 1. එකක් විතරක් 1 වලට වැඩක් නැහැ because A and B නු. Right? Then the circuit එක හිතලා අඳින්න තියෙන්නේ. F, A, B. When A and B is 1 only, the bulb lights up. Right? In all other cases, bulb is not lighting up. Right? ඒ වගේ analog circuit එකක් අඳිනවා. Clear? Next one is not, NOT not. Next, right? NOT not. Third one, NOT not. Not is the complement, right? Not is the complement, right? Not gate is symbolized as this. Not gate is symbolized as this. Like this. Not gate is symbolized like this, right? If the output is input is A, output is complement of A bar, not gate. Right? Then only one input. Since only one input, you have only one variable. Then only two possibilities. Right? A is either 0 or 1, and F is A bar. Right? 1 and 0. right? The logical idea here is when A is not 1, when A is not 1, not 1 can 0, when A is not 1, output is 1. When A is not 1, output is 1. Right? Not කියන idea. When A is not 1, output is 1. Right? Circuit try කරන්න. Use your electricity knowledge. We have done such things in electricity. Right? The circuit. Since I need a little bit more space, I'm going to take this a little bit here. Right? හරි මේ කොලම් එකේ තමයි මම මේ උඩින් අදින්නේ. Right. මේක තමයි උඩින් අදින්නේ. Right. Say you have a parallel switch like this. Right, what happens now? Now this is A. Right, switch is A. Make F figure. Switch is A. Right? When the switch is off, current passes through the bulb. It lights up. When switch is on, bulb is going to be short circuit. It's going to be a short circuit. Bulb is going to be a short circuit. Potentials are equal and not lighting up, 0. Right? So likewise, analog part is coming from electricity. Right? දැන් අපි අද ඉන්නේ ඩිජිටල් වලනේ. අද අපි වැඩ කරන්නේ ඩිජිටල් එකනේ. ඇනලොග් ඉලෙක්ට්‍රොනික්ස් ස්ටාර්ට් කරලා පස්සේ ඉලෙක්ට්‍රිසිටි වල ඔක්කොම ටික ඇවිල්ලා ඇනලොග් වලට කනෙක්ට් වෙනවා. Right? Ohm's laws, potential dividers, Kirchhoff's laws, potential writing along circuits. Right? Equivalent කරපු දේවල්. Right? ඔක්කොම ටික කනෙක්ට් වෙනවා. Right? ඉතින් මේ ඇනලොග් තමයි යූස් කරන්නේ. Electricity. Right? Finished? Raise your hand if clear up to this point. Raise your hand if clear up to this point. Right. Listen. The other circuits are other logic gates are coming as combinations of these ones. Right. අපි මේවා combine කරලා අනිත් එක හදාගන්නේ. එක එක විදිහට combine කරලා. Right. එක එක විදිහවල තියෙනවා. Right. Next one is called no. Right? No කියන එක ඇත්තටම ඒක that's a shortened form of not O. No කියලා කියන්නේ. Right? No, NOR no. Right? The shortened form of not O. Not O කියලා කියන්නේ. If a not gate is connected in front of O. බලන්න. Look at here. Not O means if a not gate is connected in front of O. Right? So this is called not O. මේකට කියන්නේ not O කියලා. It is written as no. Right? And symbolized as no gate එකක් ආයෙත් මේ not gate එකක් අඳින්නේ නැහැ. Right? Not gate එකේ මෙන්න මේ dot එකක් තියෙනවානේ. Only this dot is put to the symbol. Right? The next gate is no. Right? Next gate is no. Right? එතකොට plus වෙලා bath වෙනවා. මෙන්න මෙයාට මේ symbol එකට මේක විතරක් දානවා. Right? A plus B bar. Because if there is O, output is A plus B. Now not O. Right? Not O නේ. Now not O කියන්නේ A plus B එකේ bar එක not එක. Right. Now do it accordingly. Right? හදාගෙන යන්න තියෙන්නේ. And one more thing I actually missed. Use a red pen and mention with the not gate. Use a red pen and mention with the not gate. Mention with the not gate somewhere here or somewhere close to not gate. Only one input is applicable for not gates. Write down in red. Only one input is applicable for not gates. only one input is applicable for NOT gates. Only one input is applicable for NOT gates. Right? For other gates, number of inputs are unlimited. Right? Not a constraint for NOT, that is only one. Right? Then no, truth table and the circuit. Right? No. A plus B bar. Right? A plus B bar. Then 1, 0, 0, 0. Right? 1, 0, 0, 0. Right? Make a satisfy when a circuit tag and then node. When A or B is not on, output should be 1. Okay? When A or B is not 1, output is 1. When A or B is not 1, output is 1. Right? Electricity. Right? Whenever I think electricity. See? When I get when both A or B are off, right? Current passes through the bulb, it lights up. But if even if one switch is on, bulb is going to short circuit and it is not lighting up. Right? Not lighting up. Then next one, not AND. Not AND means when a NOT gate is connected in front of AND, that is called not AND. Shortened form is NAND. Shortened form is NAND. Shortened form is NAND. 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 Dot and bar. NAND. A dot B bar. Right? For the NOT gate, we are putting only this dot here. Only this dot here. Then A dot B bar. Truth table is 1, 1, 1, 0. Right? It was circuit tag on the right? When A and B is not 1, output should be 1. When A and B is not 1, output should be 1. Right? Satisfy another one. When both are off, bulb lights up. When one is on, still bulb lights up. Right? When both are on only, current passes through switches and bulb is shorted. Right? Finish. Next. Number 6, right? Number 6. Number 6. Right? That is called XO, EXOR, or that is also written as XOR, right? The term is coming from exclusive O. Term is coming from exclusive O, that is called XO. Exclusive O, right? Exclusive O means, right? This is a combination of two O gates, right? A combination of two O gates like this. Sorry, two O gates. Two O gates like this. A combination of two O gates like this. Maybe symbol is this one, and F. Output is written as, listen, output is written as, right, A B bar plus B A bar, right? That's a different function. That's a different function, and that's actually a complex function, right? So therefore, this function is not in A-level physics, right? But when you do higher maths, you will see this function again, right? That's a complex function. That is the XO. Then output is AB bar plus BA bar, right? Make it AB bar plus BA bar. That is a complex function because that's a combination of all gates, right? One function එක n තියෙනවා o තියෙනවා ඊට පස්සේ not තියෙනවා ඔක්කොම ටික combine වෙලා එන්නේ, right? So since there is a complex function, මේ function එක එක්ක circuit එක අඳින්න එන්නෙත් නෑ, circuit won't be asked. I mean circuit is not in the syllabus. circuit එක අඳින්නත් බෑ අතන try කළත් අඳින්න බෑ. ඕන try කළා. මේ අඳින්න බෑ කියන්නේ function එක හරියට කියන්න බෑනේ a.b bar, right? a.b bar ඊට පස්සේ b.a bar ඒ දෙක plus වෙලා තියෙන්නේ circuit එක අඳින්න බෑ. I mean at A levels you can't draw. පස්සේ පුළුවන්. When you do higher maths, you will see higher maths or higher physics. Right? Simplify these columns. Columns and rows. Simplify these rows. When both are 0, right? It becomes 0. Simplify 1. When A is 1, sorry, when A is 0, this part is 0. When B is 1, 1 A bar, 1.1 is 1. Right? Make it 1, make it 0. Simplify 1. Right? And the final gate is not XO, that is called NXO. Right? XO එක not XO. Right? That is called NXO. Not XO is called NXO. Last one. NXO. Not exclusive O. Right? Not exclusive O. Then A, B, make a not penal. F. Right? This F is AB bar plus BA bar, whole thing bar. Complete the truth table. Right? F is AB bar plus BA bar, whole thing bar. Right? 1, 0, 0, 1. Here also, analog circuit is not asked. Right? Take it down. And before moving on to the next part, you can ask if any questions or any clarifications needed up to here. Right? So after this, finish the table. Then ask if anything to be clarified before moving on to the next part. About last two gates, right? This cannot be explained using a single function. That is called a complex mathematical function. That is not a single function. ඉතින් මෙතනින් එහාට එතකොට ඒක අර plus dot and bar උනේ කොහොමද කියන එක මේ ආන්සර් එක දිහා බලලා විතරක් කියන්න බෑ. That's a complex mathematical function. Right? That's the thing. අර කලින් ඒ වගේ simple නෑ උදේ. A dot b bar plus b dot a bar එකක් නේ තියෙන්නේ. Right? That's why we keep this output in mind. Right? Anything else? Any other questions? Close the table. We are going to move on. Can I explain the simplification of the truth table? Right? මේක නිකන් plug කරලා ගන්න තියෙන්නේ. First එක simplify කරොත් a dot b bar කියලා කියන්නේ first line is 0 dot b bar කියන්නේ 1 plus b is 0 then a bar is 1 0 dot 1 කියන්නේ 0 0 plus 0 කියන්නේ 0. Right? Second line එක simplify කරොත් second එක එන්නේ a is 0 now then 0 dot b bar කියන්නේ 0 plus b කියලා කියන්නේ 1 second line එකේ ඉන්නේ b කියලා කියන්නේ 1 a bar කියලා කියන්නේ 1 1.1 1.1 is 1. I simplified that once, right? නිකම් මේකට දාලා simplify කරන්න. Anything else before moving on? Raise your hand if everything is clear up to this point now. Raise your hand if everything is clear up to this point now. Right, still you can ask if there's anything. Right? Now we are going to see some of the application types here. Right? My examples pennanna. And we'll do the other applications next day. Right? Today you will see some example applications. Right? Okay, let's move on. Let's move on. As the next heading, write down the application types තමයි කරන්න යන headings here. Right? As the next heading, write down determination of output of a given digital circuit. Write down determination of output of a given digital circuit. Write down determination of output of a given digital circuit. First one. Right? First subheading එකක් වගේ ලියන්න. Determination of output of a given digital circuit. Output of a given digital circuit. Right? Something like this. See, you will be given a circuit and you need to simplify. Right? මම example applications තමයි ඉතින් දෙන්නේ. Right? See, you will be given a circuit like this and should be simplified. And we are going to find the final answer here. Say AB and something like this given. Right? මේක output එක ලියන්න යන්නේ. Right? I will show you the first one. Right? just තව එකක් try කරන්න දෙන්න. Right? මේවා look at the board. Stop all your work and look at here. AB. Right? Now for this OR gate, signal AB are coming in. Right? A and B coming in. Right? Function of OR gate is plus, no? Right? මම රෙඩ් එක ලියන්න. Function of O is plus. Then this output is A plus B. Output is A plus B. Then this A plus B is coming up to here. Right? Then from here, this is A, up to here, that is A. This is B, up to here, that is B. Then for this AND gate, also inputs are A and B. Right? Then the output is going to be, this is not an AND, this is actually an AND gate. Then output is A dot B bar. That same signal comes to here, A dot B bar. Then this is a OR gate again. Function is plus. then final answer, it is going to add these two, a plus b plus a dot b bar, right? No need to simplify now, right? This is the final answer. Got it? Nikan simplify karena enna තියෙන්නේ. Raise your hand again if it is clear enough. We'll give another one to try by your own. Right. After this, try this second one by your own. Try this second one by your own. Try the second one. ඔයගොල්ලෝ මියුසික් ඇහෙනවද දන්නේ නැහැ මේ කට්ටිය සිං කරනවා. ඇහෙන්නේ නැන්නේ. ඔය ක්ලාස් ඉවරලා යන්න ඕනේ සිං කරන්න. මට සිං කරන්න බෑ. I can't sing but I try. But I try. Now all relatives are here. All relatives are here. So they are singing now. I can't sing actually, but I like give a try when they are singing. අර කැරකුයි මොනවද දාගෙන සිං කරනවනේ එතකොට සිං කරන්න පුළුවන්. You don't hear any music, right? මේ මම noise cancellation දාලා තියෙන්නේ. මොකුත් ඇහෙන්නේ නැහැ නේද? Right? Signals coming into the gate are A and B. Then this output is A dot B bar, that is coming to here, A dot B bar, right? From here A, then after this not gate, this is A bar, this is B, up to here B, function is plus. Then after this gate, that is A bar plus B whole thing bar, right? A bar plus B whole thing bar. This is an AND gate, right? Then final answer, right? From above A dot B bar comes, right? It is going to be dot with this one here, A bar plus B whole thing bar and whole thing bar. Right? Some expressions are simplifiable, but no need to simplify at this stage, right? සමහරව simplify කරන්න පුළුවන්. දැන් මේක simplify කරන්න පුළුවන්. But no need to simplify at this stage. දැන් මේ ඇවිල්ලා තියෙන boolean එක. මේකයි අපි boolean simplifications කලින් practice කරේ. Now we know how to simplify if needed. Right? We can simplify this if needed. For now, no need. Right? For now, no need. Right? Finished? Now, as number 2 write down, second heading, right? Second heading. අර අපි 1 කියලා දාලා මේක කරේ. Second එක දාන්න. Second heading. Drawing a digital circuit for a given output. Second one, drawing a digital circuit for a given output. 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 Right. See, now I'm going to give an output and we'll be drawing the digital circuit accordingly. Right. Say output is given as, right, A plus AB bar. Right. Meme output at the right. We are going to draw this. Right. Check the number of variables here, and easiest way is after checking number of variables, right, you can have these variables on vertical wires like this AB, right? Then A is here, right? May patte mata AB ඕනනේ, AB bar. Then take A from here, B from here. If you connect it to a NAND gate, right, what is coming out is AB bar. Then take a plus එකනේ ඕනේ. Connect these two to this gate again. See, now the output is this. Right, අරගෙන අනිත් පැත්ත the opposite of this. Right, when we draw like large circuits, considering these wires vertically is convenient. That's why I asked you to draw it vertically. නැත්නම් vertical අඳින්න ඕන කියලා එකක් නැහැ. But we will see large circuits when we are going to the questions. Right? Okay, raise your hand if this second one is also clear. Right? Now, since these things are very manageable, right, I'm moving a little bit faster, but if you have any questions, feel free to ask anything or stop me. Right? First try the second one. Output is sorry, not A plus, AB plus. Right? First one again, I make a little balloon, right? A is coming from here. I want to make a little barn, right? And AB, measuring A, this Y is A. I have taken A out from this, and this Y is B. This is an AND gate. Then after AND gate, A dot B bar comes, right? This is a O gate, right? Then A plus A dot B bar, right? Output output is A plus A dot B bar, right? You have to build up part by part and develop the final output, right? Build it part by part and develop the final output. Try this one also. right? Second one. Then you can take two wires as AB. Take two wires as AB. First, you have to create A dot B, right? A dot B. Then take the signal from A, from B, A dot B on and get tag gun. Then A dot B comes after this, right? Then I need A dot A bar dot B bar, right? Then A, then A, right? It was A bar dot B bar. This is A bar. This is A bar. And this is B bar, right? Then even though I have put a bracket here, right? No meaning for this bracket, no, right? A dot A bar dot B, right? Both circuits are correct, right? If you show it at once, you can connect all these three to an AND gate like this, and then it outputs the same thing. It outputs the same thing, right? Plus if you didn't see it, if you take it to two circuits, that's also fine. Two possible circuits are there. Two possible circuits are there, right? Because the thing is, for these gates, any number of variables are possible. Right? Finished? Then number 3, third heading, write down. Plotting output signal variation. Number 3. Plotting output signal variation. Plotting output signal variation. Plotting output signal variation for given input signal variations. For given input signal variations. For given input signal variations. Right? Look at the board again. Now instead of signals, you will be given a variation like this. Right. Look at the board. I'm going to explain using only one circuit. So look at the board carefully. Say these two are A and B, right? And now for these two, you will be given a signal variation like this. Signal variation is voltage variation. How VA changes with time, and here how VB changes with time. How VA and VB changes with time. Here variable variation right? 5 volts like this. We got 5 volts. Output variable variation right? Listen. Look at the board carefully. Look at the board carefully. Right. If the signal variation is given, right, what we do is we are converting it to the binary code. Right? 5 means 1, no? 5 means 1. Then the binary code here is 1. Second time interval is also 1, 0. Right? Maybe 0, 1, 0. Right? These two are called the binary codes. Right? Extract the binary code. Binary code is gone now. Right? Which means binary code in A is 110. Right? In A කියලා 110. B කියලා කියන්නේ මොකද්ද 010. B is 010. Right? Then these are the digits, binary codes which are coming to the gate at the time interval. No, maybe a time interval. This is the first time interval. This is the second time interval. This is the third time interval. Right? So this is the signal going to come to A and B during the same time, and this is going to come in the same time. This is going to come in the same time. Then these digits are simplified, right? According to this, time frame or the time interval, right? ඒ කියන්නේ මෙහෙමයි. දැන් first එකට මොකද්ද මෙයාට එන්නේ 0 0 නේ. මෙයාගේ function එක මොකද්ද? dot නේ. Then what it does first is 0.0. Then answer is 0. Digit twice simplify කරනවා නේද? Digit twice 1 by 1. Second time interval is right 1.1. 1.1 is 1. Third time interval 1.0 is 0. Then after this gate the output is 0 1 0. After the gate output is 0 1 0. Right, raise your hand if that first step is clear. First step means 2 steps actually, right? Identifying the binary code and simplifying. Right. Then here, see now signal A is coming through this 1 1 0. Here a NOT gate is given. Then 0 becomes 1, 1 becomes 0, 1 becomes 0, 0 0 1 we know. Alright. Then B is taken here. B is 0 1 0. This function is dot again, but there is an AND gate, right? Simplify karana. 1.0 is 0, its bar is 1. NAND gate again. 0.1 is 0, its bar is 1. 0.0 it's 0, its bar is 1 1 1 1. එහෙනම් මේ signal එක මෙතන එනවා 1 1 1. From here there is 0 1 0 0 1 0, right? Then this gate is going to plus this, right? Plus this, then 0 plus 1 1 0 1 plus 1 1 0 plus 1 1. Final output is 1 1 1, right? When the variation is given, we convert it to the binary. Now we have a binary code, then we can convert this back to output variation. 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 Then the output variation is, see, output variation is VF output with time. There are 3 time intervals, right? In all 3 time intervals, there is 1 1 1. Output variation is 1 1 1. Standard voltage is 5 volts. Output variation is 1 1 1. 1 1 1 නම් ඒකට accordingly voltage variation එක අඳිනවා. Right, simple. Voltage variation එක දුන්නා නම් binary එකට ගන්න, right? ඊට පස්සේ binary එකෙන් simplify කරන්න. Simplify කරලා අන්තිමට ආයි voltage variation එකට convert කරන්න. Right? Take it down and ask if any questions. Take it down and ask if anything you need to know. Right? Okay. Let me explain again. When you simplify the digits, it should be simplified based on this time interval. 0, 0 ne mein aage time variation in the first second these two comes in to the gate, right? In the second second these two comes in, right? In the third second these two signals comes in, right? So මේ දෙන signals මේක තියෙන්නේ time wise, right? So එකම time එකේ එන්නේ මේ දෙක. ඒක තමයි මෙයාට simplify වෙන්න ඕනේ because always gate works for that present input. Gate works, gate functions for that present input. Gate එක function and present input එකට. right? එතකොට මේක එන්නේ 0 0 නෙමෙයි. 0 0. 0.0 is 0. මේක එන්නේ 1 1. 1.1 is 1. මේක එන්නේ 1 0. 1.0 is 0. Likewise, 1 by 1 you have to simplify. Raise your hand if clear enough. Right? Next, number 4. Number 4. As number 4 write down, drawing a digital circuit for a given truth table. Number 4. Drawing a digital circuit for a given truth table. Drawing a digital circuit for a given truth table. Drawing a digital circuit for a given truth table. Right? Now, the truth table is going to give. Right? See? You are given a truth table like this. You are given a truth table like this. Say B, F. And function is not given. Only the table is given. Right? 0, 0, 1, 1. 0, 1, 0, 1. Say this is 1, 0, 1, 0. Something like this. Truth table is given. Right? So I'm going to erase this. Right, listen. The last part here. When the truth table is given, listen. When the truth table is given, right? When the truth table is given, listen. Right? So what we do is, we are picking only the rows with output becomes 1. Right? Make a standard විදියක් තියෙන්නේ. මම අnder වාසිය කියන්නම් අයියේ ගහමුනේ කියලා. Right? Listen, you are picking only the outputs with 1. Right? මේක 1 use කරලා අඳින්නත් පුළුවන්. ICT කරන සමහර අය දන්නේ නැති 0 කරලා අඳින්නත් පුළුවන්. Right? If you are doing A level ICT, right? 0 වලින් අඳින්නත් පුළුවන්, 1 වලින් අඳින්නත් පුළුවන්. I'm explaining with respect to 1. Right? Then choose the ones with rows with output 1. Right? And always we consider a given variable as 1. Listen, we consider a given variable as 1. Right? Oh, 1 as the given variable. Listen, 1 කියලා consider කරන්නේ given variable එක. And if we need 0, that is going to be considered as a bar. Right? Again, අපි හැම වෙලේම by default, listen, by default 1 means the variable and 0 means complement of the variable. Right? So likewise, we have to multiply these input variables. Now, input combination for this one is, look at the board carefully. Input combination for this one is A0 and B0. No? Then A0 means there is A bar, there is not A, there is A bar. Right? There is A bar. B becomes 0 means there is not B, there is B bar. Multiply these two. That is called A bar dot B bar. Right? And in this case, A is 1. If A is 1, there is A. B is 0, there is B bar. Right? Whatever it is coming here, right? Consider the O function of all of them. Right? Then final output is given by O function of this, then A bar dot B bar plus A B bar. Make the final output. Without simplifying this, draw the circuit here. Right? Then make the circuit because we know how to draw a digital circuit for a given output. Output new part. The new part here is finding the output. New part here is finding the output when the truth table is given, right? දැන් මේකට ඕනම් දාලා බලන්න පුළුවන් මේක satisfy කරනවද කියලා, right? මේ second line එක ඕනම් දාලා බලන්න. When a is 0, when a is 0, 0 dot anything is 0, this term is 0. When a is 0, this is 1, right? This is 1. When b is 1, b bar is 0. Then 1 dot 0 is 0. 0 plus 0 is 0. Okay? Satisfied. So likewise, even though we consider only once, all other lines in the truth table, 0 lines, are satisfied by this statement, this expression, right? And consider we are considering only one. And once this is got, then draw the respective digital circuit for this one, right? Make up here under second one, same thing. Coming from here to here is the new thing, right? Take it down. Take it down. And draw the circuit as well. Now draw the circuit as well. Draw the circuit as well. I will write something below this, right? I will write something below this. Write down below this as the first point, use a red pen, and as first point write down. Consider only the rows with final output 1. 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 Second point, multiply there, multiply there, multiply. Multiply කියන්නේ and කියන එක උදේ within brackets දාගෙන and කියලා multiply within brackets and multiply their input combinations, multiply their input combinations, multiply their input combinations, multiply their input combinations. Next point, add. Next point, add within brackets O, add within brackets O, right? Add within brackets O, all input combinations together, all input combinations together, all input combinations together, all input combinations together, and it gives the final output, and it gives the final output of the truth table, and it gives the final output of the truth table. And it gives the final output of the truth table. And it gives the final output of the truth table. Gives the final output of the truth table. Right. Now you can draw the circuit. Right. Output is A bar dot B bar plus A dot B bar. Variables are A and B. Only two variables. Variables are A and B. A, B, then A bar dot B bar. A bar comes here, right? B bar here. Then from this end, A bar dot B bar comes. Then we need A dot B bar. A is here, right? B bar is here. That is A dot B bar, right? Even if you take B bar from here, that is just fine. Right? A dot B bar, right? A dot B bar, A dot B bar. Then sum of these two. This, right? This is the final circuit. Right? Final circuit is this. Okay. Right. Again, raise your hand. Raise your hand if everything we discussed so far is clear to you. Raise hand, everyone. And if you are on YouTube, right? If you are on YouTube, you can put a thumbs up or clear or something like that. Right? Raise hand. And if you are on YouTube, you can put a thumbs up. Take a lazy. Who is this? Maheshi. Maheshi Archani. Hi, hello. Then email message jega I දැක්කෙත් නෑ. Okay, right. Let's move on. You will practice more questions on this next week. Right? Questions there, no? Question types are na. Question types nature. And from the same types, we will practice a few more questions on the route next week. Once you receive the route. Once you get the route. Right? Right. Let's move on. As the next heading, write down flip-flops. 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 Right. Anyone has come across the word flip-flop before? I mean, not in electronics, somewhere else. Anyone has come across the word flip-flop? Not in electronics, not the digital meaning I'm asking. What's the general meaning of the word flip-flop? This is a word we use day to day sometimes. I have seen the same wordings in some DSI ads, BARD ads, DSI, BARD. What does it mean? What is meant by flip-flop? Flip-flop, what's the meaning? Nobody knows. Nobody knows. Footwear, yeah. That is footwear. Footwear means that is actually what you call sandals or sandals? Slippers, sandals okay. They are flip-flop here. Right, again, if you need to put your what you call the foot into it, right? Or abidana sandals again, they are called flip-flops. Sandals sandals flip-flops, right? May word right? Let's see why flip-flops is said flip-flops here in electronics, right? Listen, flip-flop that is a special circuit. That's a special circuit, right? Made by using gates, right? Flip-flops that's a special type of a circuit made by using gates, and it has some unique features over gates as well. It has some unique features over gates. We'll see what those are, right? And when it comes to flip-flops, we can develop flip-flops using two gate types, right? Flip-flops can be developed either by using NOR gates or AND gates, right? Let's see how it goes. As a first point, write down. First point. Flip-flops can be made. Flip-flops can be made. Flip-flops can be made. Flip-flops can be made. Flip-flops can be made either by using NOR gates. Either by using NOR gates. Flip-flops can be made either by using NOR gates or NAND gates. NOR or NAND gates. Right? Then as the next subtopic, write down flip-flops by using NOR gates. Subtopic, flip-flops by using NOR gates. flip-flops by using no gates. Flip-flops by using no gates. Right. Look at the board. Right. First thing is the flip-flop circuit. Right. Look at the board. How I'm drawing the circuit. Right. Otherwise, you won't. I mean, if you didn't look at the board, you won't get the exact idea how to connect these ones properly, and sometimes you might get stuck. Right. So first of all, you have to start with the gates. No gates. No. You can draw two no gates parallelly like this. You can draw two no gates parallelly like this, and extend these inputs like this. Extend their inputs like this, and then take one of the inputs of the first one and connect it with the output of the other one, and take this input of the other one and connect this with the output of the other one. Right? This is called a flip-flop circuit. This is called a flip-flop circuit. And for flip-flops, we have a standard notations. Right? It is put as RS and Q bar. We'll see what them are. Right? We'll see what them are. Right? For a flip-flop, both R and S are inputs, and both Q and Q bar are outputs. Right? Both Q and Q bar outputs. Then there are two outputs for a flip-flop. Right? One difference over a gate, it has two outputs at the same time, and two inputs, R and S. Right? So these are the inputs. Right, now you can take down. Inputs, and both of them are outputs. Right? Then for this one, we are going to fill the truth table. Then how many inputs? Only two. Right? R and S. Then we'll have only four possibilities. Only four possibilities. Right? 0, 0, 1, 1, 0, 1, 0, 1. Two outputs, Q and Q bar. Right? Q and Q bar are, right? Q and the complement, as it says, right? Q and the complement. Q and Q bar right? Q and the complement of Q. Right? Now, you have a small task. Listen very carefully. You have a small task. Listen very carefully. Right? A small task. From the four lines, four input combinations, right? There are only two input combinations, two rows, right? Two rows that you can simplify. Listen carefully. Even though we have four rows here, right? Out of these four rows, only two rows are simplifiable. Right? Find those simplifiable two rows and simplify those two rows. Right? Right? On rows 1, 2, 3, 4 and then tell me the row number with the answer you got for Q and Q bar. Answers you got for Q and Q bar. Right? 1, 2, 3, 4 Q. Right? Right now. Anyone? Anyone? Right. The idea here is coming like this. Right. We can easily simplify O gates with 1 no, because the reason is, listen carefully, because the reason is we can easily simplify O gates with 1 because function is plus, then 1 plus anything is 1 no, right? අනිත් පැත්ත සිග්නල් එක දන්නේ නැති වුණත් කවන්නේ නැහැනේ. දැන් එක පැත්තක සිග්නල් එකක් අපි දන්නේ නැති වුණත්, if you have 1 as a known signal, 1 plus anything is 1, right? අන්න ඒ වැඩේ මම use කරනවා, right? Then I can't start simplification with 0 0, right? Because if r is 0, right, you don't know what is coming from this signal, what is coming from this terminal as a signal, right? When r is 0, ඒක දන්නේ නැහැ, right? එතකොට ඒ line එකට move කරන්න බෑ. Go to this one, 0 and 1, s is 1. I like 1 because we can simplify with 1. See, මම මේක simplify කරලා වෙන්නන්න. When s is 1, see, when s is 1, 1 plus anything coming from here, මොකක් ආවත් කවන්නේ නැහැ. 1 plus anything is 1. 1 plus anything is 1. Then its bar is going to be 0. Then q bar becomes 0. If q bar is 0, now this 0 comes from here to here. Right? මේක y එකක්නේ, 0 comes. And මම මේ simplify කරන්නේ මේ second line එකනේ. r is 0 in that second line. r is 0. Then 0.0, sorry, 0 plus 0 is 0, its bar is 1. Right? මෙන්න එක simplify වුණා. Then q is 1, q bar is 0 in the second line, right? Similarly, you can simplify the third line also. Right? Third එක simplify කරනවා නම් මේක අනිත් පැත්ත ඉතින්. Third එක simplify කරනවා නම් මේක අනිත් පැත්ත. Right? When you simplify the third one, r is 1. I like 1. r is 1 and s is 0. Right? r1 is 0. r is 1. 1 plus anything is 1. Its bar is 0. Right? එහෙනම් මේ 0 එක මෙතෙන්ට එනවා. Through this. 0 plus 0 is 0. Its bar is 1. Then q is 0 and bar is 1. Right? ඒ විදිහට මේ දෙක simplify කරන්න ඕනේ. Right. First tell me whether that simplification about these two lines are clear. Right? Our lines දෙකයි කියලා දුන්නේ. Is it clear about these two lines? Raise your hand if that is clear enough about these two lines. Quickly. Right. So about other two lines, this is how it's done. Look at here. අනිත් එක කරන්නේ මෙහෙමයි. Right? අනිත් එක කරන්නේ මෙහෙමයි. මේකේ 1 1 තියෙනවානේ. If you try to simplify, right? Listen. What is going to happen is 1 plus anything is 1. Its bar is 0. So මෙතන simplify කරනවා try කරොත් it says 1 plus anything is 1. Its bar is 0. Can you see that? You are going to get same values for q and q bar. No? In that case, you are going to get same values for q and q bar. If you try to simplify this line, right? මෙතන උත්තර 1 plus 0 is 1 plus anything is 1. Its bar is 0 කියලා. මෙතන උත්තර 1 plus 0 is 1. Its bar is 0 කියලා. Right? You are going to get same values for q and q bar. But q and q bar must be the variable and the complement. Right? So therefore, this line of a flip-flop is called invalid. This is called invalid, which means flip-flop is going to malfunction for this line. That is invalid. Right? So when we build up a circuit, develop a circuit, we have to make sure that this line is not coming into the flip-flop. Right? Right? 1 1 is invalid because q and q bar cannot have same values. That is invalid. Having same values for q and q bar is invalid. Right? ඒක logically මතක තියාගන්න ඕනේ. මේක පාඩම් කරගන්න එපා. not the logic, right? Because q and cube are supposed to be the variable and the complement, no, right? Output and the complement. But when you try to simplify using 1 and 1, you are going to get the same value. That is invalid. That is invalid. Right? Now the remaining line here is 0, 0. Right? For the line 0, 0, flip-flop cannot be simplified. Right? May flip-flop simplify for 0, 0, it cannot be simplified. Right? It simplify with na. Right? So therefore, what happens is, right, it cannot be simplified. It cannot be simplified. Right? In that scenario, flip-flop acts, right, as a memory, and the immediate previous output of the flip-flop is going to give, right? Which means flip-flop is going to have a memory, right? Which logic gates doesn't have. Logic gates don't have, right? Flip-flop solo memory at that memory functions at this scenario 0, 0 means this is not simplifiable, right? Not simplifiable state is the memory state that is called unchanged. That is called unchanged, right? Unchanged means the immediate previous output is unchanged. Memory previous output, immediate previous output is unchanged, right? So that's how the truth table of a flip-flop is filled, right? So simply make idea if you can't simplify a combination, if you can't simplify at all, right, that is the unchanged state, right? And you will get two lines which are simplifiable. And when you simplify, if you get same values for q and q bar, that is the invalid state, right? Logically logic නැත්තම් circuit එක modify කරලා දුන්නාම truth table එක ඇඳ ගන්න බැරි වෙනවා, right? මේකට පාඩම් කරගත්ත කියලා වැඩක් නැහැ, because you will get modified circuits, right? Complete it. And this line of a flip-flop is a special line, right? මේකට අපි නමක් කියනවා, right? This line කියලා කියන්නේ මේක තියෙන්නේ r equals 0 and s equals 1, right? මේ line එක, right? s equals 1, right? මේකට අපි set කියලා කියන්නේ, මම set කියලා ලියන්න. That is called the set state, right? Set එකේදී වෙන්නේ s equals 1 while r equals 0. And this state of a flip-flop is called reset. That's why r and s are put reset, right? When r equals 1, s equals 0. Right? Complete. Right? So while taking down, you can ask if anything. Write down below with a red pen. Write down below with a red pen. Mention this point below with a red pen. Mention this point below with a red pen. Red, right? Mention. Flip-flop functions with its memory. Flip-flop functions with its memory of the immediate previous output of the immediate previous product memory එකක් නෑ, only one step behind immediate previous output at in unchanged state, right? Flip-flop functions with its memory of immediate previous output in unchanged state, right? ඔහොමයි යාගේ memory එක වැඩ කරන්නේ. So which means flip-flop has a memory. Right. Raise your hand if everything is clear about this. Raise your hand if everything is clear about this. Quickly. Feel free to ask if there's anything before moving on. Feel free to ask if there's anything before moving on. No questions. Right. No questions, no? We'll move on. Right, next heading. Flip-flops by using NAND gates. Next heading. Next heading. Flip-flops by using NAND gates. 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 Right. Same thing. Replace those NOR gates with NAND gates and draw the flip-flop and complete the truth table. Draw a flip-flop and complete the truth table. Right, and these are standard notations RS Q bar. RS Q bar. Complete the truth table. And you can send your answers for this truth table. Any answers? right? Right, let's see. Let's see. Invalid, 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 unchanged. Any other answers? Any different answers? Right. Listen again. They are NAND gates. Right. Since they are NAND gates are easily simplifiable with zeros. Right. Because function is dot no. It is easily simplifiable with zeros. Right. Then start with zeros. Now, if you try with the first line, right? 0. R is 0. S is also 0. Right. Then 0 dot anything is 0. Its bar is 1. From this side also 0 dot anything is 0. Its bar is 1. Q and Q bar is going to get the same value. Same value means that is invalid. So first line here is invalid. First line is invalid. Right? First line is invalid. Then go to second line. I like 0 now because NAND gates are simplifiable with 0. Right? 0 and 1 start from 0. 0 dot anything coming from this line is 0. 0 from anything comes from this line is 0. Its bar is 1. Now from this, through this, 1 comes. 1 dot 1 is 1. Its bar is 0. Then Q1, Q bar 0. Right? Next line, 1, 0. Next line, 1, 0. Next line, 1, 0. Right? We can do this with 0 only. Then 0 dot anything is 0. Its bar is 1. Then along this 1 comes. 1 dot 1 is 1. Its bar is 0. Q is 0. Q bar becomes 1. Right? And 1 dot 1 or 1 1 cannot be simplified. 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 Cannot be simplified means unchanged. Right? That is a correct truth table. Correct. Then we must always start with R. Nothing such. Right? This can be modified as per the requirement. Right? So usually you are getting modified circuits. These are the standard circuits. Right? Even RNS can be switched as SR. Right? Even RNS can be switched as SR, or it can be modified by connecting some other gates or anything else. Right? Always this is with the logic. Always this goes with the logic. Right? Any questions so far? Any other questions? So is it clear? Right? Anything else before moving on? It is connected according to the truth table. No, truth table is filled here according to the inputs. Right, now let's see an example. Right, let's see an example. Right, no questions, no? Right, let's see an example. And the other thing, listen, before moving on, now even though we have two types of flip-flops using no on and no gates and AND gates, right? Our default case is no. Our default case is no, right? So in a question, if that is not given from which gates the flip-flop is made of, always by default we will consider it as no gates, right? අපි no එක තමයි consider කරන්නේ. NAND කියලා කිව්වොත් තමයි NAND එක යන්නේ. Right, both are possible, but our default scenario is, default case is no gates. Write down below with a red pen. Write down below with a red pen. Write down below with a red pen. Even though flip-flops can be made, even though flip-flops can be made using, even though flip-flops can be made using either none or no gates, either no or none 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 gates, no gates are considered, no gates are considered, no gates are considered as the default gate. 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 If type of gate is not specified, 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 right? Okay, now try this example. Take this down as an example. As an example, write down, write down, write down. Complete the truth table, write down. Complete the truth table, write down as an example. Complete the truth table, complete the truth table for given flip-flop circuit below. Complete the truth table for given flip-flop circuit below. Complete the truth table for given flip-flop circuit below. Complete the truth table for given flip-flop circuit below. Right. Draw a flip-flop using no gates. Draw it. Draw a flip-flop using no gates. Don't label inputs or outputs. Just draw the flip-flop. Draw a flip-flop using no gates. Draw a flip-flop using no gates. Draw a flip-flop using no gates. And complete it like this. Right, label this as R, this as S, Q, and Q bar. Right. I need the truth table of this flip-flop circuit. Give it a try and send your lines and your rows as answers. Megada Sagitta, Megada Truthe Bellagone, Mesagitta. Right. Any answers? Go. Any answers? Quickly. Anyone? I need these four. I need these 4 lines. Right? Now this is 0, 0, 1, 1, 0, 1, 0, 1. I need these 4 lines. From these parts we covered today, gates and flip-flops. We'll practice more questions next week. Right? And we have come to the end of theory parts now after this. Right? After this means now theories are over. Right? Still, this is also a practice question now. Right? We'll practice more questions. And next day itself, after finishing the questions, next week itself, I'll be starting analog electronics. Right? So in analogs, we are starting PN junctions and diodes. Right. Let's see the first one. See, first one. Now this is no gates. Then I like to simplify with 1. Right? First line, R0, S0. Right? R0, S0. When S is 0, this is 1 after the NOT gate. Right? Then 1 plus anything is 1. Its bar is 0. This 0 is coming to here. 0 plus 0. 0 plus 0 is 0. Its bar is 1. Then Q becomes 1. Q bar 0. Right? First line is done. Right? Started from S0 here. Then 1 is coming into the gate. 1 plus anything coming from this terminal is 1. Its bar is 0. Then this 0. 0 plus 0 is 0. Its bar is 1. Right? So when you simplify, that is always about understanding the concept. Right? So otherwise, when modified circuits are given, right, just by knowing the standard circuit, we can't do anything. Right? Always you have to know the concept behind this. Right? This is all about concepts. Right? Second line. 0, 1, 0, 1. R becomes 0. S is 1. When S is 1, this is 0 here. This is also 0. Right? Now, if you try to simplify with 0, right, we can't simplify this with 0. We can't simplify any of the gates with 0. Right? Can't simplify means can't simplify. Unchanged. This state is unchanged. This is unchanged. Right? Third one, 1, 0. 1, 0. R becomes 1. S becomes 0. When R is 1, this is 1. When S is 0, after the NOT gate, that is 1. Then signals 1 and 1 are coming into the flip-flop. Right? From this side also it simplifies as 0. From this side also as 0. Right? Which means you are going to get same answers for Q and Q bar. This is invalid. This line is invalid. Right? And the last one. Listen, the last one. 1, 1. R is 1. S is also 1. So after NOT gate there is 0. Right? We can simplify with 1. Then 1 plus anything is 1 here. Its bar is 0. Right? This 0 is coming to here. 0 plus 0 is 0, its by is 1. Then last line 0, 1. These are the answers. Right? So likewise, right, we have to simplify even if the modified circuit is given, and usually modified circuits are also given. Usually they are given. To simplify the flip-flop, what you need is the signal coming into the flip-flop, right? To simplify the flip-flop, what we need is a signal coming into the flip-flop, right? We need the signal coming into the flip-flop. Now understood. Can you explain how to identify unchanged and invalid? If you can't simplify the flip-flop, if you can't simplify the flip-flop, right? Can't simplify, which means unchanged, right? Even after simplifying, if you get same answers for Q and Q bar, after simplification, that is invalid. Because Q and Q bar cannot be same. These are the complements, right? 1 1 hari 0 0 hari they are complements. Then that is invalid, right? Logically, after simplifying, if you get same answers for both Q and Q bar, that is invalid. Right? Any other questions? Any other questions? Right. Raise your hand if everything is clear up to this point that we discussed today. Right? Okay, now today I have actually finished all the theory parts we have in digital, right? And we need to practice more questions. Right? All theory parts are finished. Right? Listen. Listen. So we have finished all the theory parts in digital, right? All the theory parts are finished, right? And the plans coming up next are once you get the roots this week, right? We'll practice more questions on these things we covered, right? We'll practice more questions. So first thing is applications of this, right? Few more applications of this, right? Of digital, application of digital, and after finishing digital, so next week we are starting analog. Right? In analog, we are starting PN junctions and diodes. Right? We are starting PN junctions and diodes. Diodes can time way we will start PN junctions. Right? So those are the things coming up. Right? And before winding up, again reminding about the thermal seminar. So we'll be starting at 7 tomorrow. Right? Tomorrow at 7 we'll be starting thermal practical seminar. Right? So you can join there. So if you are joining online, make yourself comfortable with the things around you, right? Especially if you are joining online, right? Make yourself comfortable with, because it will go for a kind of a long time now, right? My planned time to finish it is by 3, right? By 3, right? There can be slight changes, maybe a little bit earlier than 3 or later than 3, with the speed that you are doing the things, right? Body changes, right? Otherwise, the planned time is 3, right? So make yourself comfortable and be there if you are joining online, right? For the physical ones, you know the rules as usual, no? Right? So I'll be giving breaks also, right? අපි ඒක බලමු හෙට කතා කරමු. Right, so ready වෙලා එන්න, prepare වෙලා එන්න. Yeah, that's it. That's it. And S2S තිබ්බා last S2 එකේ හිටියේ නැත්නම් ඒවා බලන්න. Right, S2 එකේ මම structured නේ කරේ last week. Last week it was the structured from current electricity. Right, බැලුවේ නැත්නම් ඒවා මිස් වුණා නම් ඒවා ටක් ගාලා බලලා ඉවර ගන්න, because now this is a time battle. Right, just a time battle. We have come down to a time battle. Right, 9 weeks and 2 days, that's it. Right, right, 9 weeks 2 days කරන දෙයක් මේ weeks ටිකේ කරන ටික තමයි 9 weeks and 2 days. Right, next week S2 එකේ කරන්න මොනවද කියලා මම update කරන්නම් through the channels and groups. Right, එතකොට බලමු. Okay then. Right, then we'll wind up and paper class එකේ papers ටික දිගටම ලියන්න. දැන් physical count එක හොඳයි paper writing වල, but now this week also I noticed some kind of a drop in online count. Right, I don't know what the reason. Right, එතකොට ඉතින් paper එක ලියන්න නැත්නම් ඔයාලට wait කරගන්න විදියක් නැහැ, even if you are in the discussion. Now these days, මම last 2 classes කිව්වා, these days, right? So as well as you are writing the paper, discussion is also important, right? Otherwise, not only the discussion is not merely going to enough, or not only writing is not merely going to enough, right? දෙකම ඕනේ. ඊට පස්සේ marking scheme එක දුන්නාට පස්සේ අනිත් questions උත් කරලා ඔයාගේ answers check කරගන්න ඕනේ. අර ඒ වගේ දැන් කරන්න දේවල් ගොඩක් තියෙනවා. Right, so many things are coming up. We'll update you about the things in the next classes coming up. Right, okay then we'll stop. Right, we'll stop. If there's no questions, right, we'll stop. All right then stay safe, and see you tomorrow. Right, good night and goodbye, see you.